Hello students, welcome back to the session, grade 10 physics, chapter number 13, that is your magnetic effects of electric current. And here we are going to continue with part D. In part D, what we are going to discuss: electromagnetic induction, electric generator, AC and DC, that is alternating current and direct current. Electromagnetic induction, electric generator, alternating current and direct current. So first we will begin with electromagnetic induction. What do you mean by electromagnetic induction? The phenomena of producing electric current. So how you are producing electric current and where you are producing? You are producing in a conductor. And how? By changing the magnetic field. What you are doing here? You are changing the magnetic field around the conductor so that it can produce electric current. This is known as electromagnetic induction, and this phenomena was discovered by Sir Michael Faraday. Check the figure. You are bringing close the bar magnet to the coil. When you are bringing close to the coil, the magnet induces magnetic force on the coil, that is on the conductor, and by the help of the ammeter we can check the flow of the current. So what are the conditions required for electromagnetic induction? Current is induced. When the current is induced, when a magnet moves towards or away from the coil, you need to bring close and far, close and move away. So a magnet moves towards or away from a coil. A coil moves in a magnetic field. The magnetic field around the conductor changes. For example's sake, where do we use this phenomena? Electric generator, bicycle dynamo and power stations. Next comes your Fleming's right hand rule. Check the image. What you need to do here, first students, take out your right hand, stretch the thumb, forefinger and middle finger, and place all these three fingers mutually perpendicular to each other. The thumb will represent the motion of the conductor. The index finger is going to represent the direction of the magnetic field, and middle finger is going to represent the direction of induced current. So this is a way we can know the direction of induced current, direction of magnetic field and the motion of the conductor by using Fleming's right hand rule. The tips here: forefinger will representing your direction of magnetic field, thumb will represent direction of motion of conductor, middle finger will represent direction of induced current. The easy trick, FMI. FMI is the easy trick to remember. Fleming's right hand rule. Forefinger will be the magnetic field, M will be the thumb motion, and I will be the middle finger, that is your induced current. Next comes your electric generator. What is an electric generator? It is a device. So what this device will do? It will convert mechanical energy into electrical energy. And what is the principle? Principle means on what principle does it work? It works on the principle of electromagnetic induction. Check the image. The construction part. You have the here DC generator, the wire, coil, magnet, carbon brush, split rings, the main parts for it: strong magnet, rectangular coil, slip rings and carbon brushes and axle. Check the image properly. And these are the main parts in it. So the working in 4 steps we have done it. The coil rotates between the poles of the magnet. In step 2, the rotating coil cuts magnetic field lines. So what the rotating coil will do? It will cut the magnetic field line and induced current is produced. The generated current is supplied through the slip rings and carbon brushes. AC is for alternating current. Alternating current is a current whose direction changes periodically. According to the time, the current direction will change. So it will produced by an AC generator. Frequency here in India will be 50 Hertz, where it is used in homes, schools and industries. The DC and AC images. Now the DC, that is your direct current. The direct current will flow only in one direction. Sources, cells and batteries. What are the advantages of AC over DC? It can be transmitted over long distances with less power loss. That is, alternating current can be transmitted over long distances with less power loss. Voltage can be increased or decreased using transformers, more economical, and it is widely used in power distribution. So what is the differences between AC and DC? AC will change direction, DC will flow in one direction. AC is produced by AC generator, DC is produced either by a battery or DC generator. AC is used in homes, DC is used in electronic devices. AC frequency is 50 Hz and DC is 0 Hz. And next comes here a difference between electric motor and electric generator. Electric motor, which will convert the electrical energy into mechanical energy. Electric motor uses Fleming's left hand rule, and electric motor will consume electricity. What about electric generator? It will convert mechanical energy into electrical energy. It will use Fleming's right hand rule and it will produce electricity. So what are the important points here to remember? Electromagnetic induction was discovered by, yes, Michael Faraday. And what generator is going to do? It will convert mechanical energy into electrical energy. Motor converts electrical energy into mechanical energy. Fleming's left hand rule is used in motor. Fleming's right hand rule is used in generator. Domestic electrical supply in India is 220 volts, 50 hertz, alternating current. So one of the question we have solved. State the principle of an electric generator. So what is the principle? It will work on the principle of electromagnetic induction. It will work on the principle of what? Electromagnetic induction. So according to which an electric current will be induced. Where it is induced? In a conductor. When it moves through a magnetic field or when the magnetic field around it changes. So this is a principle on which electric generator, this is the principle of an electric generator. So here we come to an end of this part. We'll meet soon with the last part and we will upload it. Any queries, anything, you can WhatsApp or use the comment section. Thank you students. Good day. Take care. Bye-bye.